Naive Bayes, it is considered as the simple classification algorithm lah, that makes some strong assumption about independent of each input variable. So it is based on the Bayes theorem. Okay, this is the formula. The probability of A becoming B, okay, you have to, the probability of becoming A, we have to get the probability of B, A, and probability of A divided by probability of B. Okay, so this is the Bayes theorem, the formula. Yeah? So if you translate this, it will become like P, Y. Okay, that means this is the output. All right, and this is the input of the data. Okay, then we get the probability of X, all right, to become Y, and then probability of Y divided by probability of X. Okay, so if you don't understand, it's still okay. Later, we are going to see the example. So learning a naive Bayes model, all right, there are two types of quantities that need to be calculated from the data set of the naive Bayes model. One, it is a class probability. Another one is the conditional probability. Okay, for example, okay, let's say we have this data set. Okay, weather, sunny, rainy, sunny, rainy, rainy. So this is the data set, and this is the class. Whether the car, okay, sorry, this is the car, whether it's working or broken. Okay, working or broken. And then this is the class, whether you want to go out or you want to stay at home, right? So this is an example. Okay, so we translate this into numerical format, all right? Because machine learning, they don't calculate based on this, so we need to translate this. So this one we call it as the pre-processing. Okay, pre-processing. That means before we apply machine learning, we need to translate into something which the computer can understand. So computer understand by numbers. Okay, so you translate that. So sunny is 1, rainy is 0. Okay, so car we have working, okay, and broken is considered as 0. And then class go out here, we translate into 1. Stay home, we translate into 0. Okay, so what will be the class when the attributes are sunny working and rainy working? So from here, for human, okay, from our eyes, we can see sunny. Okay, sunny working. Sunny working, that means we go out lah. And rainy working. Rainy working. Do we see rainy working? Rainy working is not here. Okay. So we're not sure whether is it going to go out or we are going to stay home. Okay, so we can calculate this. So firstly, we calculate the probability of going out. Okay. Probability of C. Okay, so C here, which is the class. All right, the class going out, C equivalent to 1, that means it is 5/10. How I get 5/10? This one lah. This one got how many? 1, 2, 3, 4, 5. So total data how many? 10. So 5/10, that means equivalent to 0.5. And same goes to not going out. Okay, stay home, which is 5/10 also equivalent to 0.5. Right? Then we calculate the formula. Still remember our formula, it should be adhere to this formula, okay? Which I need to make sure that it must be must follow the class probability and conditional probability. So I need to calculate the probability of P whether 1 C1, okay, which is the whether it is sunny and going out. How many? All right. So we need to tabulate this. All right. So so we tabulate this first. Okay. Probability of whether 1 going out, which 0.4, which is 5 or 4/5. Okay. So for this one, you just look at C equivalent to 1. Okay. C equivalent to 1. Okay. We just look at here. All right. And then how many going out? Okay, whether the weather is sunny. So weather 1 here, 1, 2, 3, 4. So it's 4/5. Okay, so it's 4/5. All right, then we can get 0.8. Okay, so that means 4/5. And if let's say the weather is 0, okay, the weather is 0, and then C equivalent to 1. this one is only 1 over 5. Okay, how I know 1 over 5? We can go back to see the data. We only one, all right, only one data that is 0, but still go out, which is 1. The class is 1. Okay, so it's 1 over 5, that means equivalent to 0.2. And this one you do the same for whether 1 C0, whether 0 C0. Then you can get this value, right? Then you can get this value. Okay, so this process will be the same. Okay, you do for the car 1 C1. Okay, car 1 C1. So car 1 1 C1 1 C1 1 C1 1 C1. So it is 4 out of 5. Okay, so 4 out of 5. Then you get this one 4 out of 5, 1 0.8, and 0 1 1 over 5, 0.2. And if the car is equal to 1 and C0 is 1 over 5 and this one is 4 over 5. Okay, so what is the decision if it is raining and working? So you calculate this. Okay, probability of rainy and working. Rainy that means 0, working, car is working, yes, 1. All right, so to calculate this, you need to calculate the condition going out first and then condition not going out. All right, so you calculate the condition whether 0, all right, C1 times car equal 1 C1, and then times condition 1. Okay, I mean the class 1, right? Then we get the data 0.2 times 0.2 here. Okay, we whether 0 C1, okay, whether 0 C1 comes from here. Okay, whether 0 C1, all right, so that's why I can get 0.2. So I put here 0.2 times car1 C1. Car1 C1 is 0.8 times 0.8, and then probability of going out, this one is 0.5, and then I times all together, then I get 0.08. All right, so this is the decision if it is rainy and working. Okay, and if it is not going out, okay, not going out, okay, I get this data P0, whether 0 C0, whether 0 C0, which is this. Okay, this one is 3.5. I mean 3 over 5, 0.6, so 0.6 here. Car 1, okay, car 1 0 1. Okay, car 1, this one, as you can see how I choose, right? It must be the same here. Because why? Because we want to make sure it is rainy for weather. Okay, it must be rainy, so you have to select because the question you want to know whether is it rainy and working. So you must select whether it must be 0. All right, and car working, that means car, it must be 1. All right, so that's why I only choose this one, V0, car 0. Okay, car 1, whether 0, car 1. Okay, it must be like this only. Okay, because we need to confirm to this. All right, this one, it must be like this. Okay, and this one, it must be like this. All right, then the condition here, you want to know whether we are going out or not going out. Okay, and this one must confirm, okay, to the decision at here, whether you want to go out or not. Okay, so this one go out, this one go out, and this one not going out, not going out, not going out. Okay, so so for whether for the C0, okay, for the C0, we need to calculate the weather 0. Okay, we need to calculate for weather 0 C0, 0.6, and then car 1, okay, car 1 C0, which is 0.2, and then C equal to 0, this one it is 0.5. Okay, then you calculate all together, then you compare. So based on this comparison, okay, based on this comparison, which one is bigger? So we can say this one is bigger than the not going out. So that's why the decision it says go out. Okay. All right. So this one you have to make comparison lah. Okay. So between C1 and then C0, which one is bigger? So you can say lah, C1 is 0.08, C not going out is 0.06. So of course this one is bigger. Okay, so we take this up, right? Okay. So I hope you guys understand how this thing is going to work. So because this thing is actually the simplest type of algorithm which we can do it on paper, which you can write it on paper. Okay, but if let's say your data is big, then it will be difficult also lah. So you need the computer to do it for you. Okay.